In AI risk management, frameworks and lifecycle define intent, but tools and guardrails make that intent real. In the world of AI risk, policy alone can't protect us. What matters is how we operationalize trust using the right tools, applying the right techniques, and embedding guardrails that keep AI systems reliable, secure, fair, and accountable. In this episode, we'll explore how organizations build the AI risk technology stack, use techniques across lifecycle, deploy, governance tooling, and design. Guardrails that don't just monitor compliance but actually shape behavior. So, why tools and guardrails matter? Well, when we talk about responsible AI, we often hear the word what? Fairness, privacy, explainability. But the harder question is how? How do we test fairness? How do we monitor drift? How do we enforce explainability at scale? That's where tools and guardrails come in. Tools help you measure and automate controls. Guardrails ensure that every AI decision happens within defined boundaries. Think of them as the nervous systems and reflexes of your AI governance framework, constantly sensing, adjusting, and preventing harm before it happens. Let's start by visualizing it. How a AI risk stack would look like, the end to end architecture, how we implement assurance in practice. Do remember my part 1, 2, 3, and 4 to get the context of this series. We have the data layer where we do data cataloging, lineage, quality, and privacy enforcement tools. The model layer where bias detection, explainability, robustness testing is looked at. Ops layer, which includes the ML ops and the model ops. It's about continuous integration, monitoring, and deployment pipeline with control gates. We discussed gates in part 3 of this series. Then, governance layer. It involves risk registers, AI inventory, approval workflows, policy mapping. Finally, we have assurance layer, which includes your dashboards, evidence repository, audit trail systems. Together, these layers form a technical and procedural safety net from data set to decisions. Now, let's look at the technique across the life cycle. At each phase of AI risk management cycle, we use different techniques. Phase 1, which is identify. We deploy AI discovery tools that scans repositories and flag models in production. Phase 2 is assess. We use bias testing frameworks like the AIF 360, AIF, that is AI Fairness 360. We use explainability tools like SHAP or LIME, robustness testing frameworks like text attacks or adversarial robustness toolbox, and privacy impact assessment templates. In phase 3, which is mitigate, we embed human in the loop checkpoints, apply differential privacy, adversarial defense algorithms, and risk tier specific approval gates. In phase 4, monitor. We connect drift detection, fairness drift tracking, and security monitoring in a pipeline. And in phase 5, which is govern, We use governance dashboards, AI policy automation tools, and model audit trail systems. Every phase has its own instrumentation. Together, they form a continuous feedback loop. Governance platforms are the backbone of operational assurance. Leading organizations use AI governance platforms that combine multiple capabilities like AI inventory management, model lineage and documentation, policy and control mapping, approval workflow, integrated evidence log for audits. Example includes IBM Watson OpenScale or Microsoft's responsible AI dashboards or Google's model card toolkit. We have third-party platforms like Truvera, Credo AI, Fiddler AI. The key here is integration. Governance tool must talk to MLOps environment, must talk to risk register and the overall enterprise GRC systems. Otherwise, governance becomes a paper trail instead of a living system. Coming on to guardrails, let's talk about it. These are the safety boundaries that ensure AI behaves as intended. Guardrails follow four universal principles: preventive, which stops risk before it occurs; detective, which flags anomalies early on; responsiveness, and which is enabling rapid containment and correction; and adaptive, which learns and improves with feedbacks. And guardrails follow recognizable design patterns. We have four. First is input guardrails, which control what data enters the model, like data validation and consent filter. Second is model guardrails, which define acceptable model behavior, which include bias threshold, drift limit, etc. Third is output guardrails, which validates predictions before use. Human approvals for high risk results is an example. The fourth one is system guardrails, which enforces governance boundaries, which includes rule based access, audit logging, version control. A well designed guardrail doesn't slow innovation, it makes innovation safer and faster. In governance, what gets measured gets managed. That's why each guardrail should have clear metrics and thresholds. Example, say bias parity index, one of the key indicators for reviewing the fairness between groups. Model drift score, which is to provide visibility on stability over time of the model. Explainability coverage ratio, which checks for proportion of features which are interpretable. Privacy incident rates, which looks for compliance breaches per quarter maybe. Then we have security vulnerability closure rate, which is about responsiveness of defense controls. The last, the important one, is the human override rate, an indicator of human AI alignment and judgment effectiveness. These metrics are not just technical indicators, they are governance levers. They tell the board, the organization, the auditor, the regulator that assurance is quantified, not assumed. Coming on to the guardrail architecture and how it integrates. Guardrails don't work in isolation. They must be integrated into the stack. Imagine a layered architecture. The data layer runs validation and anonymization script. The model layer embeds biases and explainability checks. The ops layer automates testing during CI/CD. The governance layer enforces approval workflows, and the assurance layer captures logs and generates audit reports. This creates an end to end control mesh where every layer reinforces the other. We discussed this in our past videos. You can have a look into from part 1 to part 4. We covered this in depth. So, if a data drift alert fires, it triggers a mitigation workflow and flags the governance dashboard. Integration transforms guardrails from isolated script into a living control systems. This is what we call AI assurance architecture. Next is automation. Automation is what makes guardrails sustainable. You can't rely on humans manually testing fairness or drift week on week. Leading organizations implement integration patterns. It could be guardrail as a code, which is about embedding fairness or explainability check directly into CI/CD pipeline. The next is event driven governance, triggering control actions automatically. Then we have unified dashboards, aggregating risk signals from the AIF 360 or SHAP and monitoring tools into a single pane. Then we finally have continuous assurance loop. Risk metrics fade into governance dashboard and dashboard feeds into board reporting. Automation ensures governance is not just compliance, it becomes continuous verification. So, no matter how smart the system, human judgment remains irreplaceable. AI mitigation works best as a hybrid model. AI system performs automated testing, validation, and flagging. Human review flagged anomalies, review and interpret context, and take the technical calls. We call this human in the loop governance. For example, if a buyer's alert triggers, the tool can flag it, but only a human can decide whether it is statistically meaningful or ethically concerning. In mature program, this relationship is symbiotic. AI gives scale. Humans provide judgment. Together, they form the final assurance line, accountability. So, bringing it all together, purpose, tools, and guardrails makes AI responsible operationally. The tech stack, well, risk management spans from data to governance dashboard and so on. In short, frameworks and lifecycle gives you the blueprint, tools, guardrails. Guardrails gives you the engine. Together they form AI governance from a compliance exercise into an operational discipline. Good morning. Welcome. This is your host Savit Vittal Salian. We are in part 5 of this series and we will be looking at tools, techniques, and guardrails. For the context, this is the agenda for the complete series. We covered the first 4. For this 5th chapter, the agenda is as shown. Welcome again. Let's start the journey. Namaskar. Purpose. Frameworks and life cycle define intent, whereas tools and guardrails operationalize it. Let's now look at the three planes or the ecosystem of instruments that support the AI risk management across these. These are three assurance planes actually. The first one is technical. At the technical plane, the objective is to quantify and contain the risk. The focus here is models and data. The second plane is process. Here, the objective is to embed risk controls into the workflow. The focus is operations and governance. The third plane is cultural. Here, the objective is to sustain responsibilities at scale. Now, here, the focus is or are people and policies. So, these are the three ecosystems to support the AI risk management. Let's understand the core meaning of it. Well, frameworks and life cycle tells you what you want to achieve and why. That's framework and life cycle. Tools and guardrails help you actually do it and do it safely and consistently. In other words, frameworks and life cycle give structure, purpose and direction. Tools and guardrails turn that direction into daily practice, which is measurable, enforceable, and repeatable. It's the difference between a city plan and traffic lights. The plan defines how the city should function. That's the plan. Whereas the traffic lights make sure people follow the plan in real life. Let's break it down. Framework. The concept of framework, it actually tells you what responsible AI looks like. The function is to define the principles, standards, and objective. Example, we use NIST AI RMF or ISO 42001 or use EU AI Act. This is framework telling you what responsible AI looks like. The second concept is life cycle. In life cycle, it outlines when and how the risk should be managed. This is where you define stages and flow. How to manage risk from start to finish. Whether it is in identify stage, assess stage, mitigate, monitor stage, or govern stage. So that's the concept of life cycle. Then the concept of tools. When you do bias testing tools or drift monitoring tools or explainability engines or AI audit dashboards. The function is to provide mechanism and automation to make it happen. So that's the concept of tool. Coming on to the concept of guardrails. This is where you provide policies, controls, and limits to prevent any misuse. Like human in the loop reviews, or data access restrictions, or escalation rules, or model approval workflows. All of these are guardrails. Let's try to understand through an analogy of driving a car. The framework is the traffic code. It defines the intent, which is could be drive safely, obey limits, protect others. That's framework. The life cycle is your driving routine. You start the car, you accelerate, you steer through the navigate, you stop, and finally park. The tools are your seat belts, the mirrors, the sensors, and brakes. These are your tools. And the guardrails are the actual barriers and road signs that stop you from veering off the road, causing harm to self or others. So, without framework, everyone drives differently. Without the tools and guardrails, even good driver can crash. But together, they make safe driving possible. So, in AI risk management terms, framework and life cycle is the intent. The purpose is to set the goals, define what good AI means. Example, NIST AI RMF says AI must be explainable and fair. That's the intent. The next is the execution layer, the tools, which makes explainability measurable. That's the purpose. For this purpose, you use tools like SHAP or LIME to generate the explanation. And then we have the control layer, the guardrails. The purpose is to ensure intent is enforced. Yes, the first layer is enforced. The intent is enforced before any harm occurs. This requires human review for high risk decisions. As an example. So, framework is the why, life cycle is when and where, and tools and guardrails are how. Let's take a example to understand the context a little better. So let's take an example of BFSI loan approval AI. Step 1, the bank defines the framework. In this case, they say we will adopt ISO 42001. This is where you define AI governance intent, which is all models must be explainable and fair. The next step, they follow the NIST life cycle. The first one was a framework, the second one was the life cycle. This is defining the life cycle of build, test, deploy, monitor, and audit. I request the audience to pause here and think through. The framework they adopted is 42,000. The life cycle they are adopting are NIST. Two different concepts. The third step is they deploy the AI Fairness 360 for fairness testing, wherein they automate bias detection and scoring. This is tooling. And the fourth step, they set up human override for borderline cases, as example, to prevent blind automation errors. This is guardrails. So there is framework 42001, life cycle which is NIST, tool here is AIF 360, and guardrails is the human override option. So the framework and life cycle defines the policies and the process. The tools and the guardrails are practice and proof. So, why this distinction matters? Well, without frameworks, activity is uncoordinated. Without tools, policy stays on paper. Without guardrails, risk slips through the cracks. The magic happens when all four connect: the framework, the life cycle, the tools, and then adding the protection, which are the guardrails. So you have the policy, process, platform, protection. On all of them connect. That's where the real magic happens. Frameworks and life cycle tells us how AI should behave, and tools and guardrails make sure it actually does. Let's take an example of a restaurant. The framework is the recipe book. It defines standards for taste and hygiene. The life cycle is the cooking process: gathering materials, preparing, cooking, serving, cleaning up. The tools are the oven, the timers, the thermometers, which ensures precision. The guardrails are quality checks and kitchen safety rules. This is to prevent contamination or overcooking. So, if you only have recipes but no tools or safety rules, the food won't be consistent or safe. AI governance works exactly the same way. Key takeaways: frameworks and life cycle give AI governance its mind and method. Tools and guardrails gives it hands and reflexes. Together, they make responsible AI practical, repeatable, and provable. Let's take a look at the AI risk tech stack. The first layer is data governance and lineage. The purpose is of data quality, ensuring there is consent and provenance. The output expected is having a clear data lineage mapping and an unadulterated consent register. The tools are currently available. There are many more, but as an example, the tools and techniques, we have Colibra, Altation, Atlan, Monte Carlo, or Data Hub as a few of them. There are much many more. You can choose based on your requirement and your organization's unique demands. That is something that you'll have to test as such. I do have a video coming up on tools. You can use that as a reference if that helps you. The next layer is bias and fairness testing. This is to detect and quantify discriminatory patterns, if any. The output expected is having a bias scores and a parity report. For this, we use tools such as Fairlearn, Equitas, IBM AI Fairness 360, or Google What If tool. The next layer is explainability or interpretability. The purpose is to make models intelligible. The expected output is having a feature importance chart and an explainability index. Here we have SHAP, we have Lime, you can use integrated gradients or explainable boosting machines. The next layer is robustness and adversarial testing. The purpose is to evaluate stability and resistance. The output expected is having a robustness curves and attacks logs in place. For this, we might use full box or text attack or adversarial robustness toolbox. The next layer is privacy preservation. The purpose is to prevent any data leakage or re-hiding. The typical output here is privacy metrics and synthetic data audits. It should be able to support. We have tools such as Opacus, TensorFlow, FHE toolkit, or synthetic data generators. Do note, if you are building a tool unique for your organization, a customized one, you need to map it to one of the purpose. What is the purpose of the tool? So these layers would help you map that. Or at least that is the expectation. The next layer is model life or MLOps governance, where the purpose is versioning, approval, rollbacks. The typical output here is having a model registry with validation tags. Here we could use tools like ML flows, Uber flow, Neptune AI, weights and biases. So any tool or technique that suits you or your customized one. The next layer is monitoring and drift detection. The purpose here is to have a continuous health signals in place. Expected output is having an alert mechanism for drift and an SLO dashboard. Here we could use tools like Evidently AI, YLabs, Arize or Supervise. Moving on, the next layer is security and threat detection. The purpose is to protect the weights, APIs and prompts. The typical output here is we should be able to have our threat logs and a SOC integration in place. That's this layer of security and threat detection. You can use tools like Microsoft Presidiso, AWS Guard Duty AI or prompt injection scanners or anything that could be customized for your organization. But be very clear on the purpose. The next layer is governance and documentation. The purpose is to create an audit ready evidence. Typical output, you will have model card, you might have policy conformance report. You'll use tools like IBM Watson's OpenScale, Fiddler, Arthur AI or Giscard. The next layer is transparency and reporting. With the clear purposes, external and internal disclosures. As an output, you'll have the boards, dashboards, or regulatory tech feeds. Here, you'll use tools and techniques such as Tableau dashboards or custom AIRS portals or weight and biases report. If you look at across the life cycle, you have identify, assess, mitigate, monitor, govern. So at identify, you have examples like percentage use cases which are classified, wherein this phase you tag the risk tiers and autonomy level at intake. You use the case register. At an assess phase, you have example as average bias gap. You define the percentage, generally less than 10%, could be 5%, depending on the organization's risk appetite also. It matters. Now here risk appetite matters. For those who want to understand risk appetite, you can look at my past videos. There's a detailed explanation given on that. At this phase, you map the harms, you run fairness metrics. You use techniques such as for bias and harm scenario analysis. At the mitigate phase, you strengthen your robustness. You use techniques like counterfactual analysis, and adversarial training. Typical metrics would be what was your post attack accuracy? What's your baseline or against your baseline? The next is monitor phase. This is where you have real time input and output drift reviews. Use techniques like automated drift detection. And the final is the govern phase, where you summarize the life cycle evidence. You use model cards and transparency report. Typical metrics would be having 100% models with cards and sign offs in place. So, AI Governance Hub is a central platform. It provides unified view of model, risk, validation, incident. Example, you use IBM, could use IBM OpenScale or Fiddler or Author AI or Truera. Then comes compliance automation or the regulatory tech bridges, which maps AI risk to regulatory obligations. Could be AI Act articles or DPDP clauses. In here, you would potentially use OneTrust AI governance or Trust Arc AI or the PwC's responsible AI toolsets. That depends on your organization. So this is critical. Mapping your AI risk to regulatory obligations. Then you have model inventory and approval workflow, wherein you have automated gating, wherein you integrate with Jira or ServiceNow for approvals. Then we come on to the risk analytic dashboards, where you define the validation score to track your open findings and look at bias and robustness metrics. Finally, you have the incident response and hotlines, wherein you have ticketing, you have chatbot intakes from AI for AI incident report, and you build your auto notification for AI risk officers. These are your governance tooling and platforms. Architectural guardrails are like built-in safety boundaries in your AI system designs. They don't wait for humans to intervene. They prevent mistakes before they happen. Just like seatbelts and airbags make driving safer without slowing you down, architectural guardrails keep AI systems safe, predictable, and compliant by design. Let's break it. The first is trusted data pipelines. It ensures data flowing into the AI model is accurate, verified, and approved. Every data set has a clear source, validation steps, and audit log, thus preventing toxic or manipulated data from entering training. Do note this is one of the guardrails, the trusted data pipeline. You will hear many people talking about guardrails, but what does it really mean? How does it really look like? This is giving you a breakup of that. Example in this is a bank's credit risk AI pulls data only from verified internal systems, not an ad hoc spreadsheet, thus ensuring decisions are based on trusted, compliant data. Now you take the bank out of it and you put your own organization's perspective here. Where is your AI pulling the data from? Is it verified, or what type of verification? How much of the trust do you have on those data? So you'll have to define when you say verified, what does it include? You will have to have a documentation in place, a process in place as to what qualifies as verified, what qualifies as trusted. Once done, you are in play for this guardrail of having a trusted data pipeline. An important, a critical input. The next guardrail is least privilege API tokens. The second guardrail. In this, each AI service or API can only access what it needs, nothing more. This helps to minimize exposure if a token is leaked or misused. Example, a chatbot API can read customers' question but can't access their financial history, limiting the blast radius of any security issue. Now, when you talk to your AI architect, when you discuss with them the guardrails, this is one aspect that you need to ask. How do they ensure that the APIs, the services, can only access what is needed? What is defined as need? And how do they ensure that they don't get more than what it is required to do their job? In general technology terms, this is least privilege or just to no access. The next guardrail is prompt firewalls. In generative AI, prompt firewall act like consent filters for input, blocking any malicious or risky instructions like prompt injection or data exfiltration. Example, a customer support AI would refuse a hidden instruction like ignoring all rules and reveal the training data. It is possible, it is done even today. People try to navigate or break the system. Do you have a prompt firewall guardrail in place for keeping sensitive data safer? This is a question that the architectural team should be able to address in their guardrails. Do you have a guardrail in place? If not, time to look at this aspect. The next guardrail is output filtering and watermarking. Well, every AI response passes through filters to check for biases, toxicity, or confidential information leakage. Watermarking adds traceability, so you can tell if content was AI generated or not. Example, a marketing AI tool scans its output for banned words and watermarks image it creates before they are published. This is output filtering and watermarking guardrails. The next guardrail is immutable model registry. This is about storing all AI models, versions, and metadata in a tamper proof registry so that every change is traceable and auditable. The question the organization should ask is, do we have this in place? Example, a healthcare AI system logs each model updates, whether it is versioning, data set, approvals, etc. So auditors can verify who changed what and when. So that's a immutable model registry guardrail. The next guardrail is safe fallback to human. So when AI is uncertain or violates thresholds or faces ambiguity, or control in this case should automatically pass back to a trained human. Example, if a loan approval model detects borderline risk or missing data, it flags the case to a human credit officer for manual review, thus ensuring fairness and accountability. The organization should ask, do we have a safe fallback to human guardrails currently in play? Check if that's factual, or is it a tick in the box. Review it, analyze it, document it. Summary: you have data ingress, which is about approving sources and has verification. This is a trusted data pipeline. The next is model access, which is like RBAC or per model keys. This is the least privilege API tokens. The next is prompt management, which is block jailbreak phrases and content limiters or context limiters. This is the prompt firewall guardrail pattern. The next is inference security, which is to detect toxicity or insert invisible IDs. This is output filtering and watermarking. The next is version control, which is hash based versioning or rollbacks. This is your immutable model registry. Finally is resilience. What's your confidence threshold? This is your safe fallback to human pattern. What is the process? The first is have a pre-deployment gate. Then you have 4I principle on all high impact model approvals. Then you have a model drift SLO embedded in the SLA. Then you have a quarterly AI risk review with your CRO dashboard. And then you have an incident playbook for bias, data breach, misuse. So do note, this was your process guardrail. Now we have cultural guardrails. Cultural guardrail states, if you can't explain it, you can't deploy it. Transparency first and efficiency second. Or publicly document model limitation and expected human judgment points. Now, this is where your cultural aspect need to be asking the question to self, can I explain it? If you can't, how can you deploy it? Transparency precedes efficiency in AI, and documenting your limitation and what expected judgment from humans. Have it documented. So you have discussed architectural guardrails, process guardrails, and cultural guardrails. Let's look at some sample metrics and indicators. We have domains such as governance, fairness, explainability, robustness, privacy, security, lifecycle, incident management, and transparency. You can take a screenshot of this for reference and you can build on it. You can take it as it is also, but recommended to look at your organization's requirement and needs and customize this. This is indicative. Moving on. Let's look at a integrated guardrail architecture, a conceptual one. So now we have, for governance, we use the 42001 ISO. It covers your policies, roles, and audits. MLOps pipeline, you can use NIST RMF. For security and privacy, you can use ISO 27001. For data governance and lineage, you can use DPDP, GDPR, AI Act. For AI ethics and transparency, you have OECD or your organization principles. Now, do note, this is giving you a plethora of options for different requirements. Each layer acts as a guardrail band. The data guardrails prevent input risk. The ML of guardrails contain model risk. The governance guardrail enforces accountability. Let's try to look at an example. For bias risk, you can verify using your fairness report. For privacy risk, you have the DP audit pass certificate. For security risk, you have pen test evidence and so on. And you have various tools that you can use based on the requirement that you have. And you need to have for each risk category a control owner. Do review it whether it is one person being lazily assigned all of the risk category or there are specialized people to manage it. The larger the organization recommended to have one owner only for each risk category that provides the rigor that is required at this point of time. We are learning, we are all learning. Let's look at the integration pattern. So for continuous validation loop, you first do a code commit, then you automate tests for biases and robustness, then you have a validation report, then you have gate approval. Do note the gates were discussed in your earlier videos. I would highly recommend to look at it. This is part of the same series. Then you have, once the gate approvals are in place, then you deploy and then you monitor and finally you do a retest. You need to embed fairness, robustness and explainability test in the CI/CD pipeline, mirroring your DevSecOps. In this case, it would be RAI Ops, which is responsible AI Ops. So this is continuous validation row. The next is event-driven risk alerts. Use your event streaming to trigger AI risk alerts automatically to dashboards and Slack channels when the thresholds are breached. The last is knowledge graph for governance. Create it. Link your models to data sets, then to controls and regulations for queryable traceability. So once you do this map of knowledge across your model, data set and control, this is what will help you during your audits and reviews. You have evidences in place. Let's look at the human and AI hybrid controls. In this, the first function is bias detection. From AI, you have automated fairness scanner, but from human counterpart perspective, you have ethical panel review. Do you have that in place? If you have it, you are addressing the bias detection aspect. For explainability summary, you would have a dashboard, but the human counterpart is your business owner's approval for explainability. And the third function is policy mapping, wherein you use your regulatory tech engines, but your human counterpart would be your compliance officer's validation. The fourth is drift alert, which is from a tooling perspective, you might have an ML monitoring bot, but from a human counterpart perspective, you have ML ops leads decision. That's critical. For incident classification, you would have your NLP triage tool, or from a human perspective, you need to have an AI risk officer for your root cause analysis. Human judgment remains the override and escalation mechanism in all high impact cases. Let's look at a implementation roadmap for guardrails. As a sample for first year, for Q1 example, as a milestone, you can have a stand-up AI model registry or a risk dashboard with the key deliverables. You can define what will be a coverage. And second, you can have an part two, you can have an automated bias and explainability testing mechanism in place. Third part would be having an integrated drift and incident monitoring mechanism in place. And the fourth part would be launching your AI governance portal and transparency report. This is indicative. You can break it further what works for your organization, but this could be the top one. So once you do that, what do you achieve? Well, once you achieve it, you will be able to say our risk controls are baked into the pipeline, not bolted in. The organization can say every model passes automated fairness, robustness, and privacy test. You'd be able to say drift and incident triggers real-time alert to the AI risk dashboard, and human oversight and transparency closes the loop in our organization. This is something which you can declare provided you have at least these 4 steps in place. Again, customization to your organization need is the key here. But if you reach this stage, you have arrived from guardrail perspective. Key takeaways: tools without discipline is providing a false assurance. So you automate, but you also audit. Guardrails must span data, model, and behavior, not just codes. Integration beats silos. You need to merge your GRCs, MLOps, and security feeds together. Transparency is a control. It's not a public relation move. Finally, human oversight remains final line of defense. So in the next few years, regulators won't ask what frameworks you follow. They will ask what tools enforce them and what evidence you can produce. AI governance maturity will be measured not by how many policies you have, but how many controls you can prove are indeed working. So, start building your ecosystem of tools, techniques, and guardrails one layer at a time. Because the future of AI risk management isn't about slowing innovation, it's about accelerating it safely. I am Savit, and this is your deep dive into technology and governance behind Trustworthy AI. See you in the next episode where we'll bring these guardrails to life with real world case studies. I hope you found this useful. If so, do share with your colleagues who you think can benefit from this. Do subscribe, it helps a lot, it motivates. Subscribing it also helps for you to know when a new video is getting uploaded. Do note the intent of this video is to share as much as possible within the community and lift the overall knowledge base of the entire group. I hope you understand the context. I wish you all the luck in your implementation of AI risk. We do have few more videos to go, at least 4 more. So we have about 9 videos in this series. In addition to that, you might have one or two more videos which would pick a topic from these example tools. I would have like to create a video on those because I got a lot of queries on that space. So watch this space. Again, do like, do subscribe and do share. Your time is much appreciated. This is your host Savit Vittal Salian. Namaskar.